A nucleotide consists of a sugar molecule, either ribose in RNA or deoxyribose in DNA, attached to a phosphate group and a nitrogen-containing base. ATP is the chemical abbreviation for adenosine triphosphate as shown in here. Note that ATP has 3 chemical components: an adenine group, a ribose sugar group. Nucleotide case is only 1 phosphate group, but ATP has 3 phosphate groups linking series from a carbon fiber of the ribose. Together, the ribose and adenine groups form adenosine. Many other textbook authors have described ATP as the energy currency of the cell and explain ATP reaction like this, as shown in here. However, I would rather you study on why this is the case than simply memorizing this term. Based on this explanation of this reaction, the last phosphate group split away from ATP and rapidly releasing large amount of free energy, and this reduced the ATP to ADP and inorganic phosphate. A chemical reaction occurs when substance change into new substance with a new identity. Chemical bonds are broken and atoms rearranged and form new bonds. A chemical equation is used to express the chemical reaction. So reactance is the matter that is present before the reaction takes place. Reactants are always to the left of the arrow. And product is a matter that is present after the reaction takes place. Products are always the right of the arrow. And yield sign, the arrow is read as the word yield. What the yield sign is saying is the reactant when combined or dissolved form the product. How about this reaction about ATP? Is this really a chemical reaction? As you see, reactants need A and B, but the left side of this reaction has only one molecule, which is ATP. But the right side, which is the product part, has 2 molecules, ADP and inorganic phosphate. How it can happen? How can ATP become ADP and inorganic phosphate? Actually, the name of reaction of ATP breakdown is hydrolysis of ATP. So when an ATP molecule is combined with water, hydrolysis, and acted by an enzyme ATPases, the last phosphate group split away, rapidly releasing a large amount of free energy, and every time ATP split, release 1 proton, which is released and remain in the cytosol to contribute to acidosis. In detail, this slide is about that structural illustration of ATP hydrolysis. As you see, OH- from water molecule with the last phosphate group become inorganic phosphate and release 1 proton. If the proton released from the hydrolysis of ATP and remains in the cytosol can contribute to acidosis. So the next class will study the question entitled, where does this proton go? Yeah, see you next week.